All right. So looking at this first setup we have here, first I'm just kind of going to go over how to execute the graph. The way I like to do it is I come down to, the last node or the bottom of the network. I right click and then I go cook node and then it starts to execute. And I'm just going to kind of let this run as I talk to you, and we can kind of go over the kind of details of the nodes. Now, one of the things that you're going to notice here is as work items appear, in this case, a work item is represented by a frame. As these complete, you'll notice that the work items downstream start to pick up and execute. Um, Again, I'm rendering this locally, so all of this is happening on my own machine. But if you're on a render farm, your various different work items will be split across the different machines. So, a few kind of specifics around this, or let me talk about the benefits of this. One of the benefits of this kind of granularity in terms of dependencies is your simulation can be running, and as soon as a frame of your simulation is completed, you can start dumping out the USD file and then rendering that USD file immediately. And one of the nice things about that is you can see your kind of finished image as your simulation is executing. And say you have a 300 frame sim and you get 50 frames into it, you can look at your rendered images and be like, oh, hey, look, there's a problem there. I have to go back and adjust something in my sim. You can cancel the sim and then make your adjustment and then re-execute. The great thing about this is that there are a number of advantages. The first is it saves you man hours because you as the artist get feedback quicker and you can see if there's a problem with, your final rendered image or your simulation file or whatever the issue may be, catch that sooner, before the sim has completed, and then make adjustments and then re-execute. So it saves you man hours in terms of your time while you're working. The other thing that it does is it saves you machine time because if you are able to look at a rendered image of whatever it is that you're simulating or as it's simulating, then you can kind of check the progress as it goes. And if you need to, there's an adjustment that you need to make, you can cancel your sim and then restart. Now, the thing about that is you're saving machine time because rather than having to wait for your simulation to complete before the rendering starts, you can head it off at the pass. So you're basically you can assess if there's an issue and cancel the simulation. You don't have to wait for the simulation to kind of get to the end of its job before canceling it. So this kind of granularity of dependency and this idea that as soon as the frame of the simulation is finished, it can immediately go and start rendering. That's a level of dependencies that most render farms and schedulers haven't supported, and certainly not with the amount of control that PDG gives you. So that's the big advantage of one of the big advantages of using PDG. So let's dig in here and talk about some of the specifics of these nodes. The first thing is I'm going to talk about them a little bit more generally, and then I'll go into some of the specifics. So the first thing to kind of notice on this ROP fetch node, this ROP fetch node is responsible for caching your Pyro sim to disk. And if you come to the frames and batching tab, you'll notice that it says all frames in one batch. And what this basically means is, when you're doing a simulation in a traditional way, you generally want the simulation to be entirely on one machine because it needs to be rendered in serial, right? So in order to render frame 2, you need to know what happened on frame 1. In order to render frame 5, frames 1, 2, 3, and 4 already have to be simulated and cached to disk, because frame 5 needs the state of frame 4 to kind of continue. So turning all frames on in one batch basically specifies, hey, take all these simulation frames and run them on one machine. So that's great. But the ROP USD output, this is basically responsible for dumping out USD files. These USD files are going to act as like scene description files that are going to be rendered using this node down here. So, but this process doesn't need to be run in serial, right? It can be run in parallel. So you have options in terms of how you can do that. One of the options, the default option, is just frames per batch equal to 1. So every frame will be like a separate process that will render or will write out a separate USD file. And that works fine. For my particular setup, because the simulation runs pretty fast, I just decided to batch 10 frames. So I'm going to cancel this job and restart it so we can kind of visualize what that means. So I'm going to delete this node's output from disk, which basically means I'm going to remove all the files off disk and then restart the job from scratch. So, and I'm doing this to kind of illustrate what this frames per batch thing is doing. So you see that this is running, but ROP USD, this node will only start caching USD files to disk once at least 10 frames of the previous node have been done. That's because this is rendering in batches of 10. And so you'll see as every 10 frames of the simulation, as it finishes, another work item will start executing on the ROP USD node. So we're almost done with 30 frames. That last work item is going to finish up, and then you see it gets picked up by the ROP USD node. So batching in that respect is very useful and can be useful for things like if are, say, you're surfacing a flip sim or something like that. You may want to, rather than have each frame render individually on a separate machine as a separate process, you may want to batch them in groups of 10. And the reason why you may want to do that is because they, particularly if you're doing things like, caching geometry to disk, there's a startup cost to starting Houdini as a batch process. So if you do that individually for every frame, there's going to be that startup cost. You're going to get, say you're caching it, let's just hypothetically here, well, not hypothetically, take this example, we're rendering 50 frames. So if you were, say, doing, a surfacing step and it was 50 frames and you were going to do that, that's a process, surfacing is a process that can be done in parallel. If you were doing that, you'd have the startup cost for every frame. If you batched it into groups of 10, you'd only get that startup cost 5 times because 50 divided by 10 is 5, right? So there's an advantage in that respect as well. Okay, so the actual rendering of the frames is basically just using a single frame. You have batching options, but in our case, we're not doing that. A single frame can just render by itself individually. So yeah, let's start talking about the individual nodes a little bit and why I chose some of these nodes and the significance of them. So the first node here is a ROP fetch, and I'm using this it's pointing at a file cache node that I have in my SOP network that's basically being used to write my volumes to disk. So this isn't the only way of doing this. I'm just going to escape and stop my render. You can use a ROP geometry output node and point it at a specific SOP. So let's say I go /obj slash fireball, and I think it's Pyro look fireball. And I can point it to that node directly, which is this node here. And I can just cache to disk using this ROP geometry output node directly. And that's an option, and it's certainly legitimate. The reason why I prefer to use a ROP fetch is because when I'm working as an effects artist, it's nice to be able to make a small change and say I want to see what the first 10 frames look like. I can just come to this SOP node and hit save to disk and have it render 10 frames and stop it and kind of get that interactive feedback. And that's nice because I'm able to do that with a ROP fetch. I have the option of executing the render kind of interactively from SOPs, or I can execute it from PDG. If I was using the ROP geometry output node, the only way I'd really have to cache my geometry is from here. So that is kind of the difference. So that's why I prefer to use the ROP fetch node. Of course, what you decide to use, there's many different ways to skin a cat. Use what you're comfortable with and what you like. So we've cached our volumes to the disk. The next thing we need to handle is rendering of those volumes. So this is being done in a two-step process. We have the ROP USD output file, and then we have the USD render file nodes. So the ROP USD output file is basically, I'm pointing it at the end of my network, right? I have a null node here, I'm pointing it to the end of that, and I'm basically taking the contents of my Solaris graph and writing it to disk. And I'm doing this with the purpose of creating a scene description file. A scene description file being something that will be picked up for the exclusive purpose by a render delegate. So in my case, Karma, but it could be RenderMan or Redshift or whatever render delegate you're using to be rendered by that render delegate. USD is unique in that a USD file can be used as a means of describing an asset. So like you have a chair or a table or a kitchen set, that can be a USD file, but those things describe an asset. In this particular circumstance, I'm writing out a USD file to describe a scene description, which is going to be used exclusively to render an image. So I make a bit of a distinction there in terms of what its kind of purpose is. So that gets rendered out to disk. I like to make a separate folder for that, just to kind of be very clear that this is where my scene description files are going to, that I'm going to render. And then I have this step here where I'm actually rendering the USD file and rendering that to disk using Karma. And this is what's actually creating the image. I have this split up into these two steps for a very specific purpose. This node is going to take a Houdini license or a Houdini engine license if you're rendering on the farm. But creation of USD files is very, very quick if you've set them up properly. Like setting up a USD file as a scene description file should be very, very quick and take seconds. So and this step requires an engine license or a Houdini license. But USD render file is just rendering the USD file off disk with whatever renderer you're using. It won't use a Houdini license or a Houdini engine license. So, and that's important because rendering images, can take a long time, right? Whereas generating USDs is very, very quick. So if you can separate these two processes, it's more economical because your Houdini licenses won't be occupied during the part of the process that's actually rendering the image. And to kind of emphasize this, I'm going to show you, like, there's a different way to kind of render this. So here we have our USD render raw, and this will allow you to like render an image to disk. So hypothetically, I could have used another fetch and basically pointed this at this node and had it refer to that node. But this node is basically it'll create the image, but while it's creating the image, it's also going to be taking a Houdini license. So it's preferable to not have that happen. It's preferable to have that Houdini license be able to be used for, caching sims or caching geometry or some other application. So when you guys are rendering your images, I highly recommend that you do it using this kind of two-phased setup. All right. Yeah. So I think that's about it for this setup. In the next setup, we'll be talking about this one, which is a slightly modified version of this one I've just shown you. So I'll see you in the next video.